So now we're going to take a look in Module 4 at transformations of functions. So what is a transformation? We might think of transformers. So yes, it's transforming one thing into another. When we talk about graphs, the transformations that are possible mathematically are things that will take the graph, the curve, and it transforms it, it changes it in some way. So the types of transformations that we have are a move, translation, right? And we have a left or right movement or an up or down. So what we're going to see as we look at the different types of transformations is that they will involve either the x variable, the input variable, or the output variable. Which we can also designate, the y, or y is also another way to write y is f of x. And so we can think about things happening inside the function for the input. So that's where the change is occurring, is going to affect the x. And if it occurs on the outside, so we'll see something like f of x, out of it, so we're going to either add or subtract, we're going to multiply or divide. Anything that's done on the outside has an effect on the output function. So we have inside and outside. So we think of input is inside, output is outside. Okay. And we'll see how that affects with translations, but let's look at all the different types of transformations that we will be doing. Another type of transformation is to expand, also called a stretch, or compress, which is also called a compression, right? Or shrink. In some way, shrink. Okay. One of those two ways. And again, it can either happen inside the function or outside the function. We're going to see that what your intuition tells you is going to happen. Whenever we're inside the function, it's going to have an opposite effect. Okay, so what you think would make it stretch will actually make it shrink. What you think is going to make it shrink will actually make it stretch. When you're dealing with outside the function, stuff on the outside, it's going to happen exactly as you think it's going to happen. What you see is what you get. What you see is what you get. Okay, I don't know, make up something there. But just remember, anytime stuff starts happening outside the function is what your gut feeling is. If you think it's going to make it a stretch, it will stretch it, and so forth. And again, we'll talk through those. Finally, there is a reflection. So anytime we reflect, actually, this is kind of backwards in a way. Whenever we're going to reflect over the y, what is changing are the x values. So positive x's become negative x. That will cause a reflection. The negative x's become positive x's. So that's what's going to cause a reflection. And notice this is going to be a horizontal effect on the graph. Anything that has a horizontal effect is going to be caused by the input. Anything that has a vertical, that results in a vertical change. Vertical was changed, was caused by something changing on the outside. Okay, because when we reflect over the x-axis, right, it's the y values that are changing. So in a sense, the positive y values become negative y values, and then negative y values become positive y values. We see that it's going to reflect it right over the x. Anything on the x-axis in this case That's got a y value of 0, so you change the sign. Positive y is exactly the same thing as negative y, so that doesn't change. Same thing with the y-axis reflection. Anything that's sitting on the y-axis has an x value of 0, so its value will not change. And we'll see that directly reflected in the examples we take a look at. So first we'll go with a basic vertical shift. This is kind of what we've alluded to a few times. So if we start with a function and we add something outside that function, and again this function is take x, take the input and square it. Okay, and so we see this is the inside of the graph. The square is actually the function. It's what's happening to it. So then there's anything outside of all of this is going to be an effect vertically. Notice we put a little parentheses here. Anything that would affect horizontal has to happen inside the smaller parentheses. Okay, so let's take a look at what this looks like. Our intuition tells us, well, if we take every y value and we add 3 to it, so this is really taking our function f of x and adding 3 to it, that it will move everything up by 3 units, right? And we'll actually go ahead and use it this way. We'll do both of these to verify that that is how it works. So x squared and x squared plus 3. Let's take a look. Let's go to our Desmos, and we're going to use Desmos quite a bit to sort of in real time come up with these principles. So we're going to go with f of x. We're going to define it with function, just saying, instead of saying y equals, we'll say f of x equals x squared. So we're going to start with that as our function. There it is. What we're going to do is we will graph g of x. We'll define that as a function, but it'll be a different sort of color. And then we'll define that as x squared. Notice it looks like it's right on top of it, but if we add 3, it's moved it up, right? So that plus 3 moved it up. So what I'm going to do is let's go with one more function. We're going to just define this as, we're going to take our original function, f of x. I did it backwards again. There we go. And we're going to add to it some value. Let's just call it a. And we're going to put a slider in for a. So a is 1. So I'm going to make a, so notice when a is 0, there we go, if I can get it. You get the point. You've probably seen it. There we go, 0. It's right on top. If a is a little bit positive, every time it moves it up. So when a is 2, it's moved up 2. It's 3, it's moved it up 3. So we're adding to it. And again, if we go to the negative direction, it does kind of what it tells us. We're subtracting, so we're moving down the y-axis. So that's the effect of adding or subtracting something on the outside of a function. And again, we can kind of look at it two ways. This is the actual formula that we would use to write it. This, or a format equation, I guess we could call that. And then this is using the function notation, just taking the function and on the outside adding some value. So that gets us a transformation in terms of vertical, up or down. So we're going to either add or subtract. So that's something happening on the outside. Let's talk about reflections. I'm not quite sure I got all this order, but let's go ahead and follow this order. We'll talk about translations horizontally shortly, but you could kind of get the feel. But the reflections about an axis. So what happens for this first one, notice we're putting a negative value. Come back here. The negative is on the outside of the function, right? And so all of the output values will change. The y values will change. So as y values change, um, again, whatever, here's our x-axis, whatever was a positive y, oops, positive, was a positive y will now become a negative y, and whatever was a negative y will become a positive y. Let's just talk about this one while we're at it, and we'll start to kind of see what happens when we work inside the function. Um, so this is, notice the negative is inside the parentheses of the function itself. And so that's going to take every x value and change it. So if x was positive, it becomes negative. If x is negative, it becomes positive. And so what we're going to kind of expect is that any positive x will become a negative x, and any negative x will become a positive x. So we're going to see a reflection around the y-axis. And let's go ahead. We're in a new one. Let's see. A good one for seeing a reflection around the x-axis actually is our little friend f of x equals x squared. So we can see if I put a negative on the outside of this, what I'm going to expect to see is something like this, right? See if that happens. Let's go with this one. Okay, so let's just take our function. We'll put the negative on the outside. Um, Actually, let's do it this way. So that's the negative. I could put a parentheses around x squared, and it would emphasize that it's on the outside, and we see exactly that's what's happening. Is I get this blue graph that has reflected, and what's happened is every let's go ahead and go with that. Every y value, in this case, +4 has become -4 for the same x value, right? Um, this, I don't know, +2 at some value, probably the square root of 2, right, has become, we come straight down, has become -2. So that one's gone down there. We get so a reflection. Now there was no negative values, but if I were, we'll take a look at one that had positive and negative values. And in fact, why don't we go ahead and do that? Let's clear this out. And let's go back up here and let's change this to a cubic, because a cubic actually works both ways. Make that a cube. And then down here, we're going to change this instead of putting the function so we could look at various things. We're just going to change this to f of x, right? So it's taking whatever that function is, this cube is. I can turn it off. So we can see the cubic has got kind of this S curve. And then what happens is, in this case, anytime there is a positive x value, that same positive y value has become a negative x value. And a negative x value, let's see, this one's hard to say, sorry, negative y value becomes a positive y value. Okay, and while we're here, this will actually be a good example to take a look at of what happens when there is a reflection. So this was a reflection about the x-axis, right? So this blue one is a reflection over the x-axis. The red going down here, the red coming up here. Um, what we're going to see is that actually this reflection could also be the result of an inner reflection, because we could also think of, if we started with the red, we do it, um, let's see, what should I do? I'm going to change colors to green. I'll make the next one green. What we're going to see is that if I were to reflect it over the Y, this point would go here, and this point, this red point here, would go over there. And so let me go ahead and graph that one as f of x. Oops, it's not xx. Actually, f of minus x. So we're going to do a reflection from the inside. And notice that green is already there. That's all we had to do. So this is the same, this reflection that happened because of a negative on the outside, the y is changing, is the same thing as a reflection from the inside with a negative on the x inside. Now, this doesn't always happen. The only time this is going to happen is when we have a, uh, a function that is symmetric about the origin. So a reflection, if we have both a successive reflection around the x-axis and the y-axis, that is called a reflection around the origin. And kind of think of it, we reflect over the y and then the x, or either order, will give us, if it's symmetric about the origin, we won't be able to tell which is which. And if we do both of them, we will, as you'll see here, I'll do one more. I'll do a minus f of minus x, and you're going to see we're going to be right back on top of ourselves. Purple will be already there. It's on top of the red, right? So if I take this off, there's the red. So if I do a double reflection, we end up back on ourselves. There's another definition of odd symmetry. So a lot going on, but just notice that a negative, an opposite, will cause a reflection either over the y-axis or the x. And the way we can maybe see this a little bit is let's mess up its symmetry by doing x to the third plus something like, let's make it a little bit big. Let's go with plus 3. And that moves it up. And notice the reflections are now not the same, because it doesn't have symmetry about the origin. However, the reflection over the y, the green one, see, still does move a positive x value over to a negative x value. And then when we do the reflection about the y, so we even take this one, it's going to take what was a positive y value and make it a negative y value. So it's all still going on in here. And I encourage you to take Desmos, play around with it a little bit, and see how it all works. We're going to just delete all of that. Okay. So that's reflections. So reflect about the x-axis is, when we reflect about the x-axis is a negative on the outside affecting the y. Reflecting about the y-axis is a negative on the inside affecting the x's. Okay, so that's one of the things with the graphing. The y-axis is where x equals 0, and the x-axis is where y equals 0, and that's what makes all of that happen. Okay. Let's now talk about multiple shifts. So we can do an inner shift and an outer shift. We haven't done much talking about what would happen inside, so we'll go ahead and take a look at that. I think I've got a slide a little bit later that will specifically deal with this, but we can deal with it now. So remember I said that when we're working inside a function, that the change would be the opposite. So this -3 your gut feeling might be telling you it should move it in the negative direction 3, just like the -1 on the outside will move it down 1, right? But let's see what happens if I think of this, instead of moving in the negative direction, it's going to move into the positive direction. Is that really what's happening? Um, and of course, I wouldn't have mentioned it before if it wasn't, but uh, things that happen inside. I liken it to looking in a mirror. You look in a mirror, that passing through the mirror, because the input, everything in the mirror is backwards from what happens in reality. Your left side is your right side is your left side. So let's go ahead and take this square root function. So we'll define it as f of x again, and we'll say it's equal to the square root of x. And so now we know what the function looks like. That's what a square root function looks like. Notice there's nothing on the negative x side because those are all imaginary values. They actually graph, they would show up in the imaginary plane, but we have no way to, there's probably a way to show it, but we, in 2 dimensions, we don't have the imaginary plane. So there's our graph of square root of x, and we'll come down here, and what we're going to do is we're going to subtract 3 from the inside. So let's just do it with this notation. We'll just show that we're inside going to take our x and we're going to subtract 3. And notice it moved it 3 units from 0 to 3 in the positive direction. It moved it to the right. So we subtracted 3, but it made an opposite move. Now if we come back and add 1 to this, we'll kind of solidify everything, and then it moves up 1. Okay, so we'll do that in black. So by the +1, it then moved it up 1. So that 1 point moved, and actually every single point moved 3 to the right, 1 up. And that's why the graph looks identical, except just translated. Moved left, or sorry, moved right and then up. And so we could see, again, with using the slider technology that Desmos allows us to do, we can do f of x plus, let's just put it as a. You use any letter, and we'll do a slider. So I'll click on that. Oops, there we go. I'm going to make it 0. We'll see that it's exactly the same graph that we had, but we're also going to come back here. We're going to say add b. Why not? Could be any letter of our choosing. And then we put a slider for b. And again, let's make it 0. So that sometimes finding 0 is hard. If you use it with a keyboard, you can, I think, you can just enter in the value. Okay, we'll just go here. And notice as b is larger, it goes up. As b is negative, it comes down. So that's that effect. And the a value, as I change it because it's inside, if I make it positive, it actually goes in the negative direction. If I make it negative, it goes in the positive direction. So I can just kind of see, oh, this is how my sliders. So horizontal translation is changing the input value, adding or subtracting to the input value, and it moves in the opposite direction of sort of what I would say is your gut feeling. Negative makes it go positive, positive makes it go negative. When we're moving up and down, a positive moves you up, a negative moves you down. So you can kind of see how that works. But it's kind of just nice. You can just put in these constants such as a and b. It will ask you to put the slider, use the slider, and then you can animate the translations. And to me, since translations are really changing the graph in action, we see the effect more clearly when we animate it. Okay, so sliders, animations. So we'll come back here, and that's exactly what has happened. So let's go ahead and take a look at the next one. Um, Horizontal shifts. Now this is, I guess maybe the slide was out of place, but we've already talked about it. We've taken away our thunder, but we should be able to understand that we are inside this function, right? Here's the x. We are inside the square root, or the absolute value function. And so by adding 2, we should now see that whatever this graph is, it's going to move in the negative direction towards the negative by 2. Everything will do that. And we want to take a look at the absolute value function. It's a good one to take a look at because we do use it from time to time. You'll see it in calculus classes as well. Maybe get rid of a few of these other graphs just so that they're not going to confuse us. These old ones, there we go. So let's go with the absolute value, and we've got it right there. So, but again, let's define it as a function f of x so that we can use our little slider technology equals absolute value. So I just click on that little thing, x, and get the other side. So this is what an absolute value looks like. So in the positive direction, 2 is a point, right? 2, because the absolute value of 2 is 2. But the absolute value of negative 2 is also positive 2. So it takes all the negatives, makes them positive. You get this V shape. So let's see what happens as we change inside the function. And that would look like f of x plus 2, right? That would be putting a 2 inside the square root, or the absolute value. And as we see, it has moved it to the left. It's moved it to the left by 2 units, exactly sort of how we may have anticipated, going in the opposite. Instead of going to the right 2, it's going to go to the left 2. And again, we can come in here and we can change this inner thing to a letter. We'll call it A, get a slider, and then we can see that, yes, as we go in the positive direction, as A is positive, we're coming more in the negative direction. And as we change A to a negative number, we're subtracting from X. We're actually going in the positive direction. So, but we're just moving horizontally. Every point is moving horizontally. Okay, that's a horizontal translation. Okay, we'll leave it for now. We'll come back to this, and hopefully it's all starting to make sense. We're almost there. We've looked at reflections. We've looked at translations. I guess the next thing to look at is what happens with stretching and shrinking. So vertical is the easiest to understand. If you take any function, and let's just go ahead and go with f of x. If we multiply, so that's the sort of thing of the y function, if on the outside of this, we multiply by a number larger than 1, let's say 3, everything should get 3 times larger. And so that should stretch the graph upward or downwards, both directions, by a factor of 3. Factor of 3 in this case, or 2, whatever that number is. And if we do the same thing, but we divide by 3, or we multiply by 1/3, which is the same thing, the reciprocal, this should just do the opposite. Instead of stretching it, it should be shrinking it. And by power, a factor of 3, it's 1/3 of its original size. Okay, does that make sense? And that's exactly what's going to happen. Horizontal is going to be the opposite way around. So before we get there, but horizontal is got to affect the x, so whatever we're doing has to happen inside. So if we do by 1/3, remember inside is always opposite, so what's the opposite of 1/3? Well, that's actually multiplying by 3. This is going to be a horizontal stretch. And we'll see that happen. And inside, if we multiply by a number bigger than 1, and 1 is the trading place, or the place where things switch, right? Because when we multiply by 1, it doesn't grow or shrink, it stays the same. But this is going to be a shrink, again, in the horizontal direction. And again, sometimes with these graphs, depending upon what we're doing, it's hard to tell the difference between a vertical stretch and a horizontal shrink. They both kind of look the same, and we'll take a look at that. But if we see the function, what we're given and what's being done, we can tell, okay, if they give us this was definitely a horizontal shrink. It'll have the same effect because basically it's coming from, right, it's squeezing it from the left and the right. And so it's going to squeeze it, up. And so it's actually going to stretch it horizontally. It'll look like a stretch horizontally, even when it's just being pushed in. Okay. And when you're stretching something horizontally, you're pulling it out, and so you're making it wider, and so it's going to look like a vertical shrink because vertically things look like they're going down. Okay, so let's take a look at those, and then we're almost finished. We'll put it all together. But a good function to take a look at with horizontal stretching and shrinking is what do I want to say? Parabolas. Parabolas are always good because we get this U shape, and so as we come below, if we're going to do a stretch, we'll see that things will go up higher. When we shrink it, things go down lower. So let's go here, and let's remember that's on the outside. So let's put a 3 times f of x. And so the blue one, you can kind of see that everything has been stretched upward. It looks like, yeah, if you stretch it up, it's going to make it thinner. Like thinking of, what's that, silly putty. I don't know if they still got that stuff around. When we were kids, you put it on the cartoons, especially the Sunday cartoons were in color. Who gets newspapers anymore? I don't know. But we used to put that silly putty, it would take the color, and then you could stretch it in any direction. And yeah, if you stretch vertically, that's kind of what it's going to look like. And then thinking of if we were to do it by 1/3, 1 divided by 3, and then we multiply that times f of x on the outside, we then see the green representing a horizontal shrinking. So in that case, every y value is it's not going directly down. It's not a translation, but it's the value. Let's see, what would be the value of 6? So if you were to take that value, divide it by 3, you should get 2, right? And that looks like about right if we came straight down. Yeah, that's about 2. So 6 divided by 3 is 2. If you did 9, 9's about here. If you divide it by 3, you end up at 3, and that's about right. We're a little bit off the graph here. So we can bring this down a little bit. Let's delete all of that. And so that's what's happening, is it's a shrink in that direction. Now the thing is if we were to do these in the x direction, we might not really be able to see what was going on. But let's go ahead and, well, actually, let's do this. Let's change this to a variable. Let's make it a constant variable, so we'll make it like a, make a slider for it. Let's turn off this other one. And we see that, okay, when a is 1, nothing's going to happen because 1 times it is the original. But if we make it bigger, we're stretching, think of it, it's stretching it upwards, which makes it look thinner. Each y value is going up that way. And if we Now this is a thing, it's not about being negative, but if it's less than 1, right, that's the reciprocal, and then we get a vertical shrinking. It's actually becoming the y value. So any particular y value is smaller. Now the thing is if we go below 0, then it becomes negative, and we should get a reflection, which we do. Okay, so we still get that same sort of thing. So once we bring in the negative, though, we're putting in a reflection on top of a stretch or a shrink. So that's all that does. So really we're looking for the stretch and shrinks. We're looking at values greater than 0 specifically. And so the point is between 0 and 1 will shrink, and 1 or greater will stretch it. Okay, so we don't really need that anymore. Now what we're going to do is while we're working at this, let's see what happens. What if we were to move the A inside? So we're going to come here. We'll delete that, and we'll put an A inside A times. Okay, so now we're changing the inside, and what we're thinking in terms of, so if we go to 1 first, right on the function. If we're less than 1, watch what happens. Think of that. What's that? If you were to describe that horizontally, it is a stretch, right? We are stretching it this way. We're pulling it outward. That's a horizontal stretch. Anything less than 1, right? Between 1 and 0. And then again, we get that reflection again if it's negative. But it's inside reflection, so you can't really see it. If it's larger than 1, notice it's a compression this time. It's pulling it inward as long as we're greater than 1. And we kind of squeezing it. And notice that looks the same thing as a vertical stretch. So again, a vertical stretch can be accomplished by a horizontal compression. That's why these things are opposites of each other. Okay, so these are kind of thinking, is there a change happening inside or outside? That tells us whether inside is always horizontal, and vertical always happens from something being done outside the function. So to the f of x, to the whole function. Think about putting a whole parentheses around the function, anything on the outside onto it. Okay, so we're going to take a look at one more, and this will kind of put everything together, and what we'll do is we'll see if we can anticipate what's going to happen here. And if you follow along with order of operations in mind, you'll always be in right stead. Now sometimes you could do them without following the order of operations, but it just depends on where it is. Sometimes it's important, sometimes it's not. So I say, why not always follow the order of operations, and you'll always be fine. Okay, so first of all, order of operations start with inside the parentheses. So what I see here is basically what we're working from is the base function, right? Y equals f of x, or sorry, y equals x squared, or f of x equals x squared. We'll take that as a base function. Inside, we are going to do a translation, a move, a horizontal move, to the right, yeah, in the positive direction. And I like to show the arrows. What's going to happen? It's going to go to right. And then, okay, so now I come out, then I'm going to square it. That's actually the function. What happens next? Well, I get multiplied by, again, I want to think of this as 1/4. I'm going to deal with that negative separately. So I'm going to, 1/4 is on the outside of the function. So that's going to be a shrink. And what direction? It's on the outside, so that is a vertical vertical shrink by 4. So it's like dividing by 4, right? 4 times magnitude. So that takes care of that part. So we've got a 1, first step, second step, and in order of operations, the next thing that's happening is negation right here. So then I'm going to reflect. I think this all works. Again, sometimes that's where the problem is do I reflect before or after I add the 3? And try this with following order of operations. So the negative causes it's on the outside, it's going to reflect. Since it's on the outside, it's changing the y value, so it's reflect over the x-axis. And then the final thing that should happen is the +3 is a vertical. It's a shift, a move up, right? Because we're adding 3, up 3. And again, we can put our arrow there. So let's see if we can do each of those moves. We'll start with x squared, subtract 2 from the inside, we'll multiply by 1/4, we'll see that happens, and then we'll subtract 1, and then we'll add 3, and see if all of these moves work out as we anticipated. So let's go ahead and put f of x. We'll just make it equal to the base function, which is x squared. So there's that. We'll come down and we're going to take f of x, and the first thing we're going to do is inside that function we're going to add 2, and that should move it right. Oh, are we adding 2 or subtracting 2? I forgot. We're subtracting 2. Yeah, because I thought we were moving to the right. Get rid of these ones as we're going through. So go over. Let's change that to a minus. Okay, so we did move to the right. Now let's come back. Let's multiply by 1/4 and see if vertically it shrinks. Now vertical shrink, because it's on the outside, what should be happening is that this blue function, it should look wider, right? Somehow by about a factor of 4. Should look wider. That's a vertical shrink is what's going to happen. So we come to the front. Oops, what happened there? Lost my x's. Okay, see if it works. We're going to put in 1 divided by 4, the front, and it does. It's made it wider. Okay, so that is a shrinking vertically. And watch when I put this negative out front, it reflects it, and then I'm going to come and move everything up 3. And that's what's going to happen there, thinking of that order of operations. Now if I moved it up 3 and then reflected, that would still look pretty much the same. No, I don't think it would, because if I would have moved it up 3 and then when I reflect it, that would have been a positive 3. Anyway, following order of operations, you get the right movements. Okay, so this is what it's going to look like, and just follow along with the inside. Excellent. Back to here. So that puts all the movements together. We have taken a look at transformations in Module 4. Remember, horizontally Horizontal translations are caused by stuff being done inside the function. Let's change to blue. And vertical changes are by stuff happening outside the function. Okay. And again, we can add, subtract, multiply, divide. Those are the main things we have. And then we have reflections, which are caused by the negative or the opposite. Happens, reflection caused by a negative, either inside the function or outside the function. So take a look at the learning activities for Module 4 with all of this in mind. Seek assistance through our online tutoring, our office hours, or working with peers through the discussion forum. And again, in the discussion forums, if you do a screenshot of what you're working on, that's helpful. And show any work that you've done so far. All right. Good luck.